Hi, so I've had these Class 20 locomotives. I've got two of them, this one and this one, since I think about 2007, and they're not really the best runners. Principle of operation is pretty much the same as the Brighton Bell, also done by Wrenn. You have a power bogie and a trailing bogie, which is the same chassis as the power bogie. The power bogie has got traction tires on one side, and it picks up power from the other side into the chassis via the axles. This one basically is sitting on the track, the opposite to that, and it does the same thing without traction tires, so it picks up on the other rail with two wheels. If you've got good track, it's probably okay. The locomotive's fairly heavy, so connectivity's not that bad. The traction tires, if you accelerate or decelerate too quickly, will tend to make the locomotive derail, as it does a mini wheelie. So what I decided to do was experiment joining these two together, nose to nose here. This was done quite a bit, certainly around the area where I live and lived at the time. These were quite prevalent on the railway. Just as an aside, this one here has got a different chassis. It's I presume an earlier chassis. It's not branded, neither covers are branded, but this chassis pair here are actually branded Wrenn, so I've got to assume these are newer, probably a cost savings to cut down on the metal. However, the benefit is I was able to build in this board here and a relay. And what I've done as well is coupling them together. In the wiring here, I pass the track power from one to the other, which greatly improves the track connectivity as they effectively back each other up electrically, and because they're physically connected together mechanically. So if one of them has a stutter, the other one is obviously feeding it the power, but it's also either pushing or pulling it depending on which one goes and in which direction the unit's running. I've also put end lighting just on the cab ends of the locomotive. It's probably easier to see that one. I'll show that on the layout because you can then see the lights running. What is in here is a coach lighting super capacitor circuit, which means that when the locomotive is stopped, the lighting stays on for a period of time. And this relay is a bistable relay. It can exist in two states without requiring power. It's got a double coil, so you fire one coil, the relay sits in one position, fire the other coil, it goes in the other position. And that has the effect of reversing which side is red and which side is white lights. I did the lighting with 1mm optic fibre to translate or to bring the light from the surface mount LEDs to the surface of the locomotive itself. The LEDs are a bit footery to work with, if I'm honest. Tying it down onto a bit of cardboard with insulating tape and then just soldering directly to them seems a reasonably effective way of doing it. In one case I just hardwired them together using solid wire, and in the other I used a small piece of strip board to support the LEDs and to maintain the correct separation, as there's nothing really in the locomotive to align them exactly on the holes and the optic fibre. So I found probably the strip board the better method, but it's then slightly more difficult to try to insulate the light from shining inside the locomotive and appearing at the cab. But I did that with a combination of black tack and black nail varnish. The nail varnish wasn't mine, incidentally. I 3D printed this plastic part to hold the coach lighting continuity unit and a bistable relay. Like most of these types of projects, you start off thinking you've got plenty of space to do what you want to do, and then you come to do it and the space seems to get hugely smaller than it had been in the first instance. So, as can be seen here, this might be better with the floodlights out. We're seeing a white light on the front, and now we're seeing twin reds, and the same is happening at the other end. One of the things that's really nice though is, in comparison to the way they used to be, the slow running is excellent. Let me just get closer to some point work. So this is 1950s technology with a little assistance, but the assistance has nothing to do with the electronics controlling the lights. This is just simply two pretty well serviced locomotives helping each other. This is pulse width modulation at about 125 Hertz, which I find for these old locomotives is probably optimal. There's absolutely no overheating that I can detect. And I don't think there's a clock showing on the video, but those lights, having now run this for a minute or so, they'll stay on for minutes. And the circuit I've used has got a 3-volt low dropout regulator on it, so they do get a bit dimmer as time goes on, but they extinguish just over a period of a few seconds when the super capacitor has got discharged down to about 3.2, 3.3 volts, which is about where the LDO no longer manages to provide an output. For those of you with sharp eyes, you might notice that the crew is actually manned. My own 3D printed, custom sized little men to fit in there in front of the bogie without fouling it.